After we've calculated the t-test statistic or computed it from software, we want to compare the test statistic with a critical value or set of values. Again, the critical value is going to be based on whatever we set alpha to. And then for a two-sided test where the alternative is that the population mean does not equal the claimed value of the null, if the absolute value of our test statistic is greater than our value of t alpha divided by 2, then we're going to reject the null. For a right-sided test, in which the alternative is that the population mean is greater than the claimed value of the null, if our t-test statistic is greater than or equal to t alpha, then we reject the null. And for a left-sided test where the alternative is that the population mean is less than the claimed value, then if our t-test statistic is less than or equal to negative t alpha, then we reject the null. Now, the key point here is that our test statistics and p-values, they all change, right? Since the shape of the t-distribution changes with the sample size, for a given level of alpha in a t-test statistic, the corresponding p-value will change. So with a smaller sample size, the p-value will be higher. That is, it is less likely we will actually reject the null hypothesis. This is just reflecting the greater uncertainty with inferences based on smaller samples. And again, the critical values based on the t-distribution change. The shape of the t-distribution, it just changes depending on the sample size n. And so for a given level of alpha, with a smaller sample size, the critical values of t alpha divided by 2, t alpha, and negative t alpha, they'll be more extreme. That is, it is more difficult to reject the null hypothesis. With a larger sample size, these critical values will be similar to those from a standard normal distribution. Right? So let's examine what's going on. Let's suppose we have a two-sided t-test with alpha of 0.05 and a sample size of 3. So you can see that if we set alpha to 0.05, all right, our actual critical value is going to be around 3. Right? It's going to be negative or positive 3. Our rejection region is that if we have a test statistic in more extreme than positive 3 roughly, or less than negative 3 roughly. Right? For a sample size of 10, right, those critical values are a little bit lower. Right? We have roughly negative 2.2 and roughly positive 2.2. Right? If we have a sample size of 500, right, on the t-distribution, the critical values are similar to those with a rounding error of the standard normal distribution. So with a larger sample size, the t-distribution approximates the standard normal distribution, and our t critical values are negative 1.96 and positive 1.96 roughly. And so you can see that the critical values change depending on our sample size, and the critical values are the benchmark by which we interpret our t-test statistic. Right? And we can compare this with a two-sided z-test. Right? We have critical values of negative 1.6 and positive 1.96. And so the key point here is to examine, right, how these critical values and p-values change depending on the nature of the t-distribution.